Hello, I welcome you all in this course of basic real analysis. As you're aware that we were doing questions on Cauchy's sequences, and today we are going to continue from there onwards. And let us wait for a few people to join in, and then we shall start. Okay, so this is the uh, as I told you that Cauchy sequence is an important topic for your exam also, and I have done quite many questions for you. Now today let us do a few more of the same variety, and then once we are done with this, then we'll be moving on to the new theorem, which is the Cauchy's convergence criterion theorem. Now yesterday I was discussing with you one of the important properties, one of the important you can say result. So one of the important result here it was result was, what was the important result? An important result yesterday that I discussed with you was this. So what I discussed, so I actually discussed that if at all xn plus 1 minus of xn mod is less than equal to bn, okay, if this is the case and summation bn is a convergent series and summation bn is a convergent series, then xn is also convergent. Then xn is also convergent. Just give me a minute. Just give me a minute. Okay. Okay. Then summation bn is a convergent series. Okay. Now you see how did this happen? So I told you that whenever such kind of I told you one of the tricks, that is whenever you have to say that sequence is Cauchy, you have to estimate xm minus xn modulus, and that too for all m greater than n greater than equal to some number, let's say naught, and this is how you do it. So in order to quantify that a sequence is a Cauchy sequence, so I'll say that xm minus xn, I will have to estimate xm minus xn, estimate xm minus xn for all m greater than n greater than equals to n not belongs to natural. So we have to estimate this at first. Now you see, whatever hint has been given to you, it has been given in terms of the consecutive numbers, consecutive you can say elements. Okay, so what would I do? I would actually, I'm just stating it here. This is your n, this would be your n plus 1, this would be your n plus 2, and I can say that this would be my m minus 1, and this would be my simply m. Okay, so if I go like this, I can write xm. Here I can write xm minus of 1, then plus xm minus 1, xm of minus 2, plus xm minus 2 minus xm minus 3, and then at the end I will have xn plus 2 minus of xn plus 1 plus xn plus 1 minus of xn. Okay, this is what we have to estimate, and I know by modular inequalities that this would be less than equal to xm minus of xm minus 1 modulus plus xm minus 1 minus of xm minus 2 modulus plus xm minus 2 minus of xm minus 3 modulus, and then you will have this xn plus 2 minus of xn plus 1 modulus, and then at the end you will have xn plus 1 minus xn modulus. Okay, now you know that this is less than, this is what, this is less than bn minus 1, sorry, this would be less than bm minus 1, this would be less than bm minus 2 by the hint. Okay, so you just see the actual hint given in the question, and at the end you will have simply bn. Okay, it would be less than the modulus of it. So if it is all positive, then it's fine. But if it's negative, some of the terms are negative, then I can say it would be less than modulus of all these things that are written. And now just understand that summation Bn is given to be a convergence series. So I'm just writing it here, those who have no idea of right now of series. So always remember that if a series is said to be convergent if and only if a series, so let's say I'm saying summation Bn is convergent. So if I'm saying summation Bn is convergent, what does it imply? It implies that the sequence of partial sum associated is also convergent. Okay, so if you're not aware of it, few lectures I have taken for mathematical physics people. There I have taught you this thing in quite basic. However, I'm going to teach you some, don't worry about it. I'm going to teach you series, but right now this concept is being used. So for example, you know that from your BSc section that summation 1 upon n square is convergent. You know that summation 1 upon n ki power p is convergent if p is greater than 1. Okay, if p is equal to 1, then it is divergent, and if p lies between 0 and 1, that is also divergent. Overall, just remember that if summation Bn is convergent, then the sequence of partial sum associated with it is convergent. What does it mean? So let's say this is your series. So I'm writing series would be summation k equals to 1 to infinity bk. This is my series. And what would be the sequence of partial sum associated with it? Let us write it as Sn. So what would be Sn? It would be b1 plus b2 plus b3 dash 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 bn. So this is your sequence of partial sum. Okay, so always remember if this okay. So what does it mean? It means that if my sequence of if my series is convergent, then the sequence of partial sum must be convergent. If this series is convergent, then the sequence of partial sum must be convergent. It implies that my sequence Sn must be convergent, right? Must be convergent. Okay, now just think about this. If I'm saying that my sequence of partial sum, that is Sn, is convergent, what does it imply? It implies that Sm minus of Sn mod can be made less than epsilon for all m greater than n greater than equals to n naught belongs to natural. Okay, now you just think about this. What was given to you? It was given to you that xm minus xn mod is less than modulus of bm minus 1 plus bm minus 2 plus bm minus 3 dash 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 dash. At the end you are given as b, you are given bn. What does it imply? Just think about this. If I write Sm, what it would be equals to? It would be equals to b1 plus b2 plus b3 dash 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 dash. You have a bn, and then you will have a bn plus 1. Then you will have bn plus 2 and dash 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 dash. At the end you will have bm minus 1, and then you will have a bm. Okay, so if I'm saying I'm adding from bm minus 1 to bn, if I'm adding to bn minus 1 to bm, rather I would say that if this is the case, then do one thing. I think there is some mistake somewhere. Just think about this. Xm minus xn now. So xm minus 1, this is fine. Xm minus, okay, this is fine. And if you just think about it, if this is m, then this is m minus 1, and if it let's say this is n plus 1, this is n, so you had a bn here, so obviously it is all right. Now you just think about it. So xm minus xn modulus is less than bm minus 1 plus bm minus 2 plus bm minus 3 dash 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 bn. Okay. Now if I try to find what is this, if I try to find what is this, is it not equal to, so if I'm writing what would be sm minus 1, sm minus 1 would go till m minus 1, right? And if I subtract sm minus 1 from sn minus 1, if I subtract sm minus 1 from sn minus 1 and take a modulus, I will get it equivalent to bm minus 1 plus bm minus 2 dash 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 bn only. This is what I'm going to get. This is what I'm going to get. So if sequence is Cauchy, then sm minus sn ka mod can be made less than epsilon. Similarly, sm minus 1 sn minus 1 modulus can also be made less than epsilon. It implies what? It implies that modulus of xm minus xn can be made less than epsilon for all m minus 1 greater than n minus 1. So instead of this, I'm writing n minus 1 and n minus 1. So instead of m and n, you have this greater than equals to n naught belongs to natural. If I add 1, so that would give me what? It would give me that xn minus of xn modulus can be made less than epsilon for all m greater than n greater than equal to n naught plus 1, or let's say that be a new natural number, let's say capital N. So what does it imply? It implies that the sequence xn is convergent. For exam, please remember this result. This is an important result. I'm stating it here right away. Please remember this result. Remember. Again, I'm stating what is the result. If xm minus xn modulus is written less than or equal to bn, and summation bn is a convergent series. Summation bn is a convergent series, then the sequence xn is convergent. Then the sequence xn is convergent. Please remember this. This is an important result. This is an important. Even if you don't follow this entire proof, if you remember this result, this will be more than sufficient for you. Now let us do one question from your exam only. Let us do one of the questions from your exam only, and it is an important question. It was asked in your TIFR examination, as much as I remember, and let me write down that for you. The question that was stated was, just let me open the TIFR papers. Okay, so the question that was stated to us was this. Okay, so in exam it was stated, so this is a TIFR question that I'm solving it for you. Okay, so this is a TIFR question that I'm solving it for you. Okay, this is TIFR. And what is the question? Question says, let an be a sequence of real numbers. Let an be a sequence of real numbers such that modulus of an plus 1 minus an mod can be written less than equal to n square upon 2 raised to power n for all n belongs to natural. Then option number A, sequence an must be unbounded. Must be unbounded. Option number B, sequence an is bounded but may not converge. Is bounded but may not converge. Option number C, you have an has exactly 2 limit points. Has exactly 2 limit points. And option number D that was given was an is convergent. What do you think answer would be? An is convergent. What do you think answer would be? What do you think answer would be? So, see, all these questions are given to you in exam because they know uh, if it comes to exam, these are not very uh, those questions that usually people would prefer. Okay, so basically TFR is meant to make your life difficult, but I'm here to make your life easy. So let us do this particular question. So I hope you have noted the question. Now I'll try to solve this particular question that was asked in TFR examination. Okay, so in any case, if most of the people, if you are attending net exam or gate exam, please remember the series is closely associated with sequences. So most often in examination, a lone sequence question you cannot expect. There would be a chance that a sequence question comes, and along with that a series input would be there. So for example, this particular question. Now let us try to do this question. So an plus 1 minus an mod is less than equal to n square upon 2 ki power n. So let me do this for you. Okay, so just think about this. So given to us is what? It is told. Okay, what is given to us? It is given to us is given that modulus of an plus 1 minus an mod is less than equal to n square upon 2 raised to power n. Okay, now just think about this. Think about this. So if I have to write 2, can I not write it as e raised to power log e 2? This is also actually 2 only, and I'll take e raised to power. I'll take 2 raised to power n. So basically what I have done, I have written 2 ki power n in this form. Why I have written this particular thing? And always remember, this is your Riemann zeta function 2, or you can say summation 1 upon n square. Summation 1 upon n square is a convergent series. Even if you have attended your BSc first year, and probably in physics if you have attended Bayes and oscillations, there mostly teachers do Fourier analysis, and from Fourier analysis they write this, that 1 upon n square is pi square over 6. I'm not saying that is the only way, but if you are in BSc starting, then always remember summation 1 upon n square is a convergent series. It is a convergent series. Just remember this. It is a convergent series. If it is a convergent series, then the sequence associated with it will also be convergent. So what is the sequence associated with it? 1 plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square dash 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 1 upon n square. So this will also be convergent. This will always be convergent. Remember this. So if a series is convergent, then the sequence of partial sum associated with this is also convergent. Okay. Now try and what I have done. I have written this deliberately. Why I have written this deliberately? Because I know the series of E. So I can write 2 ki power n is nothing but it is equal to 1 plus, instead of x, what do I have? Instead of x I have e ki power n log 2. Okay, instead of x I have, because you know now e raised to, this will be equal to writing e raised to power n log 2. Okay, this is equal to this. So it will be 1 plus x. So I'll write n ln 2 plus n ln 2 whole square divided by 2 factorial. Similarly, I can write n ln 2 whole cube divided by 3 factorial. Then I will say write n ln 2 raised to power 4 upon 4 factorial, so on and so forth. Okay, now I know that I know already that all these terms are, see, ln2 is positive, n is positive, so all these terms are positive. So can I not write that 2 raised to power n will be greater than n ln2 raised to power 4 divided by 4 factorial? See, all these terms are positive, so these are being added to this. So if I singly compare it, so if I compare only n ln 2 raised to power 4 upon 4 factorial, so I can clearly write that 2 ki power n would be greater than n ln 2 raised to power 4 upon 4 factorial. I think it is clear to everyone. And I can also write that 1 upon 2 ki power n would be less than 4 factorial divided by n ln 2 raised to power 4, right? So 1 upon 2 ki power n will be less than 4 factorial upon n ln to raised to power 4. So in other words, I would say that an plus 1 minus of an modulus is less than equal to it was less than equal to n square upon 2 ki power n, and I know 1 upon 2 ki power n is less than this, so I can write 4 factorial divided by ln to raised to power 4, and this is n raised to power 4. Here you have n square and here you have n raised to power 4. So I can clearly write that an plus 1 minus of an mod can be written less than 4 factorial divided by ln 2 raised to power 4 times 1 upon n square. Okay, and this is a constant, this is a constant, and remember the result that I taught you, that if an plus 1 minus of an mod can be written less than equal to or simply less than bn, such that summation bn is a convergent series, then the sequence an is convergent, then sequence an is convergent. Similarly, here if you just see this particular series is convergent, you have a constant multiplied with it, so it hardly matters. So overall I can write that my an is a convergent sequence. I hope it is clear. Please let me know in the comment section if there is any problem. I hope it is clear. So an is convergent, option number D. So I'll wait for a minute or so and then we'll again start. So I hope everybody has got this particular problem. If there is any doubt, please let me know so that I'll wait for a minute, then I'll start with the new problem. Okay. So I hope most of them have got the answer. Now what I will do is I'll take another problem and then just try to use this particular theorem there if possible. Try to use this particular theorem there if possible. So let me give you a problem and then see how many people do it. Then let us see how many people do it. Okay. So given to you is C. Okay, so let us see. Let us now write a few more questions. Question: if an is a sequence, which satisfies this, that is an minus of an minus 1 modulus less than equal to n plus 1 raised to power n divided by n raised to power 2 upon 3 plus n. If this is your this is the condition, does it imply that an is a convergent sequence? Does it imply that an is a convergent sequence? Does it imply that an is a convergent sequence? Think about it. Think about this. Just think about this. This is an easy question. Think about it. I think this is not 2 by 3. This is 3 by 2. Sorry. This is 3 by 2. Okay. So now let us solve it. Always remember. I'm telling you, those who have not been exposed to your series section, I'm just writing it for you. Always remember that summation 1 upon n ki power p is a convergent series. It is a convergent series. Always remember this. When p is greater than 1. When p is greater than 1. Now, just think about another thing. is called as a limit comparison test. So in order to identify that my series is convergent or not, one of the tests is called as the limit comparison test, in which what we do, we compare. Let's say if you have a series summation an, and if you have another series, let's say summation bn, you know about the convergence of bn, you are sure about convergence of bn, but you are not sure about the convergence of an. What you can do, just take the limit, an upon bn. If this limit comes out to be non-zero, and here an is greater than 0, and bn is also greater than 0. So what I want to say, I'm talking about two positive term series, that is summation an and summation bn. I don't know about summation n, what is the whether it is convergent or not, but I am sure about convergence of bn. Then what I can do, I can use limit comparison test. In limit comparison test, what I have to do, I have to take limit n tends to infinity an upon bn. If this limit comes out to be non-zero, then an and bn, summation an and summation bn behave alike. That is, summation an and summation bn both converge or diverge together. Both converge or diverge together. So that implies what? That implies if an is convergent, then bn is if bn is convergent, then an is convergent. If bn is divergent, then an is divergent. This is what it means. Now, as I told you, the result was what? The result was this. So if I have the condition an minus of an minus 1 modulus less than equal to bn, and summation bn is convergent. If summation bn is convergent, then I can say that summation an would be convergent. So this question narrows down to finding the convergence of the series n plus 1 raised to power n divided by n raised to power 3 by 2 plus n. So it boils down to finding whether this particular term on the right hand side is convergent or not. So what would I do? I would simply do one thing, and that is this. So I'll use a limit comparison test here. So I'll compare n plus 1 raised to power n divided by n raised to power 3 by 2 into n raised to power n by 1 upon n ki power 3 by 2. So what I'll do, I'll compare these two things. I already know that 1 upon n ki power 3 by 2 is convergent. Why it is convergent? Because this is like 1 upon n ki power p, where p is greater than 1. So clearly this is convergent. Clearly this is convergent. Now I have to assert the convergence of what? Now I have to assert the convergence of this particular series, that is summation n plus 1 raised to power n upon n ki power 3 by 2 n ki power n. So what will happen? This will get cancelled. Now you just see what is the limit here. So limit n tends to infinity. You just take n raised to power n common. So just take n outside. So this will give you 1 plus 1 upon n raised to power n. So if you just write this particular thing, just write this particular thing as this. So what you are getting the ratio as simply e, which is certainly non-zero. Now since it is non-zero, then it implies that this series and this series behave alike, and I know that summation 1 upon n ki power 3 by 2 is convergent. That implies summation n plus 1 raised to power n divided by n raised to power 3 by 2 times n raised to power n is convergent series. And I have already stated a powerful statement that if if an minus of an minus 1 modulus is less than equal to or less than bn, and summation bn is convergent, so this is convergent, then it implies, this is your bn here, then it implies what? That it implies that an is a Cauchy sequence, or an is a convergent sequence. I hope it is quite clear to you. Okay, so these are all very important kind of statements that you should remember. Now let us do another question. and then we'll take a break for today. I hope this concept you've got. Now try to do this question. What is the question? Question says that if an minus of an plus 1 modulus is less than equal to n times log of n divided by e raised to power n, then an is Cauchy, true or false? Then an is Cauchy, true or false? Then an is Cauchy, true or false? So let me do this question for you. Now just think about this. I told you that if this particular term bn, if this is some, if I take a summation bn here, if summation bn is convergent, then it implies sequence an is convergent. Now you think about this. Just think about this. I'm making a graph here, and just think about this. If I make a graph of a log, and if I make a graph of x, which do you think is superior? Clearly, y is equal to x is superior. It will go from origin. So I can write that log of n is always less than n. I can write that log of n is always less than n. It implies n ln n is always less than n square, and I can write n ln n upon e ki power n is always less than n square upon e ki power n. Okay, I just stated a few minutes before that if I write e raised to power n as 1 plus n square upon 2 factorial plus n cube upon 3 factorial plus n raised to power 4 upon 4 factorial plus so on and so forth, then just think about this. This is positive, this is positive. Can I not write that my e raised to power n would be greater than n ki power 4 upon 4 factorial? I hope it is clear. So I can write my e raised to power n greater than n ki power 4 upon 4 factorial. So similarly, I can say that my n ln n upon e ki power n is less than n square upon e ki power n, and which is less than certainly 4 factorial divided by n raised to power 4. Okay, and this will get cancelled, so you will have an n square here. So what did I get? I got that an minus of an plus 1 mod is less than 1 upon n square. I taught you that summation 1 upon n square is convergent. It implies that sequence an is also convergent. I hope it is clear. Okay, so all these things you should keep in mind. These are some very good questions, and these are all exam questions I'm giving you. Now try to do one more question regarding I think Cauchy sequence only, and then I think you'll be able to understand what I want to convey. So even if you see the exams also, they are going to ask most often regarding Cauchy sequences. Okay, regarding Cauchy sequences, they are going to ask you most often some questions. Okay, so let us see a few more questions regarding Cauchy sequence. Okay, so question says that, what is the question? Question says that, just give me a minute, I'll let you know the question. Okay, so question says that, this is the question. Suppose that, this is the last question in the series today. The question says that, suppose that xn is a sequence. Suppose that xn is a sequence of real numbers. Suppose that xn is a sequence of real numbers satisfying the following. And what is the following? Following was given to you. This is I think exam question. Okay, it was asked in net examination. Suppose that for every epsilon greater than 0, there exists n naught belongs to natural number such that modulus of xn plus 1 minus xn mod can be made less than epsilon for all n greater than equals to n naught belongs to natural, then xn is Cauchy. Xn is Cauchy. True or false? I'm not giving you options. I'm just asking a true and false statement. So just think about it. So yesterday itself I told you that the sequence, if I'm writing the sequence, let's say this is my sequence. Let's say this is my sequence xn equals to 1 plus 1 by 2 plus 1 by 3 dash 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 1 upon n. Just take this sequence. Okay, just take this sequence. Now if I take xn plus 1 minus of xn mod, what am I going to get? What would be your xn plus 1? Xn plus 1 would be simply taking this entire sum 1 plus 1 by 2 plus 1 by 3 dash 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 1 upon n, and then you will get 1 upon n plus 1 here. So this would be your xn plus 1. And now you can clearly see that if I write xn plus 1 minus xn ka mod, what it would be? It would be simply equals to 1 upon n plus 1, right? So if this is your xn, right? This is your xn. From here to here, this is your xn, right? So if I write xn plus 1 minus xn ka mod, it would be equals to 1 upon n plus 1, right? And I already know that if I take the limit n tends to infinity, 1 upon n plus 1, this would be equal to what? 0. And if this is equal to 0, then it implies 1 upon n plus 1 minus 0 ka distance can be made less than epsilon for all n greater than equals to some n naught. What does it imply? It implies that xn plus 1 minus xn mod can be made less than epsilon for all n greater than equals to n naught belongs to natural. But xn is not Cauchy. See, this particular sequence is not a Cauchy sequence. This is what we have proved in last class. But xn is not a Cauchy sequence. Xn is not a Cauchy sequence. So answer would be clearly false. So xn is Cauchy? No, not necessary. Okay. So I hope everybody has got some sort of insight. Tomorrow I'll do a few more questions on Cauchy sequences, and from day after we are going to start with the monotone convergence criteria. All these questions that I'm sharing to you is to develop an insight about this epsilon del approach. If you are well acquainted with it, if you are well aware of this particular approach, then surely you're going to clear your exam. That is one. And secondly, in interviews also you will fare out very well, because mostly you will be judged upon this writing skill of real analysis. Even if you have cleared your net examination somehow by understanding how to do some options and everything, it is very sure that you're going to get stuck in your interviews. So please keep in mind whatever basic real analysis right now I'm teaching you, although it may seem to you very basic, but these are quite important questions for your academic future. So wishing you all the best for your academic future. I hope you will join in numbers in next session. Till then, take care. Bye bye.